Hello everyone. A little while ago I put out a challenge for anyone interested to try and program a tiny chess bot. The challenge came with a simple framework for things like getting the legal moves in the current position, keeping track of which pieces are on which squares, and so on. But the actual brains of the bot was entirely up to the contestants, because out of the box it played like this. As an extra challenge, entries were also limited to just 1,024 tokens of code, where a token is a single element such as a variable name, an operator, and so on, and doesn't include things like comments, which are of course for human eyes only. This is countered by the C# compiler, which turns the code into something called a syntax tree, as a first step towards translating it to something more machine-readable. So all of the leaves of this tree are the tokens, which count towards the limit. An alternative approach would have been to simply limit the size of the source file, although then you're compelled to minify everything, turning variable names into a single letter, removing whitespace and line breaks, and so on. In hindsight though, maybe providing a script to just do that stuff automatically would have been a better approach, because while I tried to think of all the possible exploits ahead of time, as soon as the challenge was announced, people of course started scheming up clever ways to cheat the system. Such as using this line directive, which I've never heard of in all my life, to store an arbitrary amount of data inside of an error message. And this is handled as a pre-processing step, so it wasn't getting counted towards the limit, and one could then intentionally trigger the error and extract the message. Several such creative workarounds were reported and outlawed in the first day or two, but one huge exploit remained undiscovered until just before the end. It turns out I had accidentally used an outdated version of the C# compiler to do the counting, which meant that in some fairly obscure cases it could become confused by new language features and start miscounting the subsequent tokens. Only one entry actually risked using this exploit though, and just to gain about 30 tokens in the end, so thankfully it didn't undermine the whole tournament. Now, a few bots did unfortunately exceed the token limit in the regular way, and so sadly I'll have to disqualify those. There are also a few bots disqualified due to compilation errors, most of which were just blank entries, and then a number of bots used namespaces that technically were not in the allowed set, but after reviewing them manually, this really isn't giving them an advantage, I'd say, so I'm going to be lenient there. With the exception of the bot Not At All, which was the only entry to try and sneak a network connection into the code to fetch moves from a web server. At least, I hope it was the only one. In any case, we're at last ready to begin the tournament. And with 626 bots competing, this is probably going to take around 48 hours to run. So while this is going, let me just talk about the format quickly. This is a giant Swiss tournament, which means that in the first round the bots are paired up randomly, but after that bots with similar scores are paired together, so long as they haven't played each other already. Now this is going to go on for 64 rounds, so that's about 20,000 games, which I hope will give enough time for the strongest bots to work their way up to the top of the rankings. Then once the Swiss is complete, the top 64 will play a final knockout tournament to determine the overall winner. These games are played with 1 minute per side, by the way, and in a slight change of plans there's also a 0.1 second increment after each move, just to mitigate the overhead of running a bunch of games in parallel. Alright, now I'm excited to see how everyone has gone about implementing their bots, so let's just pick one at random and take a look. Turochamp Faithful by Pure Rivero was one of a couple of attempts at recreating possibly the first chess program ever written by computing legend Alan Turing and David Champernowne, although it was never actually successfully run on a computer and had to be painstakingly executed by hand. Some details of the original implementation have unfortunately been lost to time, but a classic mini-mech search was used here along with alpha-beta pruning to speed it up. The author does note that alpha-beta pruning hadn't actually been invented yet at this point, but that Turing couldn't be bothered to consider moves that were obviously bad when running it by hand at least, so it seems faithful enough to put it in. Although the speed isn't actually needed here, since for similar reasons the search has been limited to looking a maximum of 3 moves ahead. I was impressed to see though that the original authors had already come up with this extremely important idea of a quiescent search, where that main search is extended to examine all possible captures so that the evaluation function doesn't have to worry about the complexities of trades or sacrifices. Now, in this evaluation function, we can see that each type of piece has been assigned a material score so that it can count up the value of the pieces on the board. Beyond that, it also gives a mobility bonus to each piece, and we can see here that this treats captures as 2 moves to incentivize attacking the enemy, I suppose. It then takes the square root of that, meaning it's very good to have at least a handful of moves available to each piece, but after that it doesn't matter as much. Anyway, each piece also gets a safety bonus if it's protected by another friendly pawn or piece, with an extra bonus if it's defended more than once. This doesn't apply to the queen though, which makes sense because it's so valuable that it almost always has to run away if it's attacked. And the king is also excluded from this, but it actually has its own personal safety term here, where we look at how many moves it would be able to make if it were a queen, and then treat that mobility score as a penalty to encourage keeping the king covered up. It also gives a bonus to pawns based on how far up the board they've managed to move, while being defended by non-pawns in particular for some reason. Finally, it has some incentives coded in for castling, or being able to castle in the future as well. So let's see how this historical bot fares against a random competitor. WhateverBot by Alec Holden is one of a handful of entries that attempts to play a decent game of chess while never looking further than 1 move ahead. So over here we can see that it has a little routine for finding out which of its pieces are in danger, which it does by making a list of all pieces that attack or defend the current square, sorted from least to most valuable. It then goes through these lists to see whether the opponent has a lower value piece that will be able to capture a higher value piece. This does have a pretty major flaw though, in that the attackers and defenders are only determined at the start of the capture sequence, which excludes pieces that are stacked behind one another. That is tricky to handle without actually doing a proper search though, which would go against the premise of this bot. So anyway, it then gives a score to each move based on several rules of thumb, such as advancing the central pawns, developing the minor pieces, and castling of course. It also aims to capture the highest value enemy piece with its own lowest value piece, along with an added bonus if the captured piece was threatening one of those pieces it detected earlier to be under attack. Then over here, it does do a little test to see if any of the opponent's immediate responses can put it in checkmate, which I guess could be considered as looking an extra move ahead, but whatever. It then has a bunch of code for trying to figure out whether making this move will endanger the moved piece, or any of its comrades, and applies penalties based on that, before finally choosing at random from the most promising moves it's found. So quite an involved process, but it's definitely an interesting challenge to avoid the very thing that makes computers so good at chess, which is of course their ability to crunch through tons of positions. The WhateverBot seems to be doing a good job so far of not giving away its pieces, while Turochamp makes some highly dubious pawn moves around its king. I have a feeling this game won't be decided by the finer points of strategy, however. And sure enough, here we have a horrific blunder that's tricky to detect if you're only looking 1 move ahead. I'm not sure why black failed to protect the knight though, there must have been a sneaky bug in the logic. Anyway, let's see how this ends. Okay, now I'm curious to see where these bots ended up in the rankings. So out of 626 competitors, Turochamp Faithful managed to come in 215th. And by the way, the modern version with an unlimited depth and some minor tweaks achieved an impressive ranking of 85th, almost good enough to make it into the upcoming knockout round. WhateverBot, meanwhile, finished near the top of the bottom half with a ranking of 385. Just for fun, let's see it playing a quick game against Pawntress, which was another attempt at this 1-move look-ahead strategy. Obviously, this is not exactly the most scintillating chess to be found, but there's some fun to be had in watching them flail around, I suppose. And I think it was a cool self-imposed challenge that these two authors, and several others, decided to take on. And by the way, here's what their games look like when they're not being slowed down. So Pawntress managed to win this particular game, and in the tournament achieved a rank of 338. I'm going to start uncovering some of the surrounding rankings as well, because we won't have time to look at all of the bots individually, of course. But I certainly want to explore a bunch more, so let's grab another one at random. And here we have applemethod-orz by Red Black Tree. This bot takes a very simple approach to evaluating positions. All it does is assign a value to each type of piece, and then adds those up. Actually, there's also a tiny bonus given to whoever's turn it is to move, plus a random jiggle to the score to prevent the bot from repeating moves when it doesn't know what else to do. The way it searches positions is interesting though. We can see it's given a node budget based on how much time it has remaining, and then it starts by guessing the evaluation using the function we just saw, and if it has exceeded its node budget, then it returns that as the final evaluation. Otherwise, it gets all the possible moves, and assigns each of them a weight based on the evaluation of the current position, plus the evaluation after each move has been made. And this is intended to gauge how promising each move is, because I guess a high value capture would get a large weight, for example. And then based on that, each of them is given a fraction of the remaining node budget to use for further investigation inside of this alpha-beta search. I wonder if this is any good, so let's pull up another random opponent for it to play against. Igris by Deathfile78. This bot has a big table of scores for different types of pieces based on what squares they're on, known as a p-square table, although the author mentioned that they had to leave out the scores for kings, queens, and rooks due to running out of tokens, so some kind of compression scheme might be necessary when using a p-square table approach in this challenge. Performance was also mentioned as a big struggle, which I think everyone writing a chess engine can relate to. But some unsolicited advice I'd like to give here is to avoid constantly reversing the lookup tables to flip between the white and black perspectives. It is a nice intuitive approach, but it's going to slow things down a lot, and it would be much more efficient to leave the array untouched and instead figure out how to adjust the indices based on whose turn it is to move. In any case, the given move is assigned a score based on how much the piece likes the square it's moving to, versus how much it liked the square that it was on already. There's also a function for counting up the material values of all the pieces on the board, and these two functions are used together to evaluate each move inside of the getBestMove function, which searches recursively to a fixed depth of 3ply to avoid using up too much time. Some extra bonuses are also assigned in here, for example encouraging pawns to move forwards when there aren't many pieces left on the board, and also favouring moves that promote a pawn, castle the king, or put the opponent in check. A list of the best moves is made throughout this process, and one of those is picked at random to be played. So let's watch these two bots fight it out. Okay, a strange knight sacrifice here, and I think what happened is that this knight is trapped, so black saw that instead of letting white capture it for free, it could sacrifice the other one and at least win a pawn. What's unfortunate though is that the first knight is actually still trapped, black just didn't see far enough ahead to realize it. This is a problem that plagues any chess engine that makes the grave mistake of not looking infinitely far ahead, which is of course all of them, although stronger engines do use many tricks and techniques to try and see further in critical lines. Okay, applemethod is just cleaning up at the moment, and now a deep think before delivering checkmate. Let's have a look at the rankings. So Igris ended up in rank 306, and I'll again reveal some of the surrounding neighbours here. Applemethod, meanwhile, achieved a ranking of 232, which is quite impressive, especially considering that it only used up about half of the token limit. So I thought it might be interesting to make a little plot. In this plot, we have the number of tokens used by each bot on the x-axis, versus the ranking of the bot on the y-axis, going from worst to best. Let's see how that comes out. So unsurprisingly, we can see that the very top entries up here have indeed all squeezed pretty much every drop out of the token budget. Although so too interestingly have some of the lowest ranked, such as BadAppleBot. I wonder if that's doing what I think it might be doing. So a week or two into the contest, I found that a lot of people were understandably getting a bit confused with the bitboard API I provided, which lets you figure out stuff like which squares is the enemy currently attacking, for example. So I patched in a little helper function to visualize the bitboard, meaning that now instead of just being given some mysterious number to work with, you could actually see what that value represents. So if you're familiar with the bad apple phenomenon, you probably already know where this is going, but let's nonetheless load the bot in and let it run. For anyone out of the loop, this music video has been played in pretty much every conceivable way, from graphing functions on calculators, to sheep in Minecraft, to oscilloscopes, and now bitboards, I guess. Hopefully someone in the comments can explain the lore behind it though, because I don't know anything about that. Now, this obviously doesn't have tremendous merit as a chess engine, but I am still curious to have a quick look at how this was actually implemented, because it does seem like quite a lot of data that needs to be packed into the size limit. So the author mentions that this is their first time experimenting with video compression, but they've come up with the nice idea of storing the number of frames that pass for each pixel before it toggles color, since of course the video is purely black and white. They also had the idea to store those frame counts with varying numbers of bits, to be able to take advantage of the fact that some pixels tend to switch color more frequently than others. So we can see that hunk of data over here, which is the first 2 minutes of the song before the bot ran out of tokens. Then here's how it's being decompressed and played back. I thought that was a fun concept, and it shared the honor with Worst Bot Ever Made of coming, of course, in dead last. Let's return to this plot for a moment though, because another thing that caught my eye was this little cluster of outliers that used few tokens, but seem to have performed disproportionately well. These are SSComp1, DLComp2, and most successful of the trio, the 200 Tokens Monstrosity. The author, ONF, seemingly made it their mission to create the strongest bot possible within their own personal 200 token limit, because apparently I was far too generous with the constraints. Let's open it up and take a look at the code. There's not much of it. So what's going on in here? We can see it's searching through all the moves and first sorting them actually, so that high value captures, for instance, are looked at early on, since those are most likely to be good. It also stops looking at all moves and instead only considers captures once this depth variable drops below 0 here, in order to combine the main search and the quiescent search into a single function. But I want to focus on this interesting little evaluation scheme over here. First of all, the values of all the pieces have been packed into a single integer to save space, and that's then converted into an array of bytes and indexed by the type of piece that was captured or promoted. Here's what those values actually look like, and they're a little strange, especially seeing that capturing a knight and promoting to a queen is considered better than capturing a queen and promoting to a queen, but corners obviously had to be cut for compression, so that's fair enough. I find it interesting that it's scoring individual captures and adding them up as they occur throughout the search, instead of having a big loop to count all of the pieces that are remaining at the end, like one usually does. Since it only tracks the change in pieces, that can obviously backfire in certain cases. For example, here's a position where white would be winning if black didn't have this annoying little infinite check maneuver. However, if we play this against the 200 token monstrosity, it has no idea that it's down a million pieces, and just sees that it can win a rook. But that's again a creative compromise to save a bunch of tokens. Another interesting idea in the evaluation is that it factors the mobility of pieces into the score by counting the number of legal moves, similar to what we saw in Turochamp, but instead of the square root, it takes the logarithm of that, which means that when the number of legal moves is 0, the score becomes infinitely negative, which means that the bot doesn't need to have an extra condition to test for checkmate. Anyway, one last thing I want to mention is this disturbing way that the author managed to save a handful of tokens in the time management code here. The idea is that when the bot has been thinking for 30 times longer than it has time left on the clock, this value will become negative. Trying to convert it to an unsigned value will then throw an error, which will be caught and ignored over here to immediately exit the search. Absolutely disgusting stuff. I love to see it. Now let's see how this plays against Baby Squid. This is a bot by game developer and fellow YouTuber Jonas Tiroler, and it's one of only a handful of bots I've seen so far to actually dedicate some precious space to include its own minuscule book of openings. As we can see, it's been instructed in the ways of the Sicilian. Now, much like the monstrosity, this bot evaluates moves instead of positions, and this is done firstly by calculating how much the move improves the position of the piece, where pawns are considered better further up the board, and knights and bishops better closer to the center. Somewhat strangely, no guidance is given to rooks, queens, or the king though. Anyway, along with bonuses for capturing or promoting pieces, there's also an extra evaluation term that gets applied only if this is the last move we're looking at in the current line. In here, a mobility bonus is given for the difference between how many moves are available to us versus were available to the opponent on the previous turn, and then there's also a penalty applied if the move places a piece on a square that's under attack by the enemy, which seems to be intended as an alternative to doing a whole quiescent search. So some unconventional ideas here, which is always fun to see. And now let's watch them play. So Baby Squid going with the Sicilian of course, and the monstrosity bringing its queen out very early, which is not particularly wise, but it's trying to maximize the number of legal moves, so it makes sense from that perspective. Okay, the queens have been traded off, and we have a position with equal material where both sides have some awkward pieces, such as black's bishop wedged in on g2, although it is actually doing a great job of keeping white's rook pinned down. It currently doesn't have any way of getting into the game. White's light square bishop is also very awkward, and I'm not sure how that's going to get into the game either. So Baby Squid seems to be in the driver's seat at the moment. Okay, but the tables have turned very quickly here, and now pawn d5 is almost checkmate. Black can only go to e7, which is a very uncomfortable place to be on account of this check, which is just waiting to happen. So the monstrosity is now up a rook for a knight, and all of its pieces have managed to enter the game, so this is looking very grim now for Baby Squid. Alright, let's take a look at the rankings. So Baby Squid achieved a ranking of 137 with a score of 33.5 points out of 64. The 200 tokens monstrosity meanwhile scored just half a point more in the tournament, which was enough to put it in 118th. So we can see the scores are very tightly packed in this region of the leaderboard at least. Tiebreaks, if anyone cares to know, are calculated using the median Buchholz system, which is just the sum of the scores of your opponents, with some of the best and worst scores excluded to try and avoid bias from the early rounds, where the pairings are still quite random. Anyway, let's have a look at another entry. TinyHugeBot by Puffx21 and ATPX8. This entry caught my eye partly because in the description it says, "We know we might be disqualified." Let's see what that's all about. First of all, where's all the code? This thing is tiny. Oh wait, it's tiny vertically, but horizontally, it's actually quite humongous. So what this team has done is very interesting. They've built this bot builder TinyFire, which is almost 2,000 lines of code for compressing and optimizing DLL files. In addition to that month-long project, they spent another month writing the actual chess engine called HugeBot, which, true to its name, is indeed rather huge. For example, let's just briefly look at one section of this, the static exchange evaluation. This function tests whether a sequence of captures is good or bad without having to run the actual search, kind of like what we saw back in WhateverBot, but a lot more rigorous. although I think it still doesn't handle pins against the king, so it's not 100% accurate. But the idea is to use this as an optimization to save some time in the quiescent search by skipping over captures that the static exchange says are bad. Just the code for doing that is already over the limit though, and in total this bot takes up exactly 5,000 out of the 1,024 available tokens. So to make it comply with the rules, this engine was then compiled to a DLL file, squeezed down and optimized with their custom tinifier, then embedded into their actual submission using a custom compression scheme based on run length encoding. At runtime, that data is then decompressed into the raw bytes before being loaded and executed using a part of the C# API that prior to this I had no idea even existed. Using this sneaky approach, the authors could probably have simply embedded some powerful pre-existing chess engine, but I really like that they went to the trouble of making their own engine anyway. I think that's way cooler. Now, just for fun, I want to see this playing against the 200 Tokens Monstrosity to find out just how much of a difference those extra 4,800 tokens have made. Okay, TinyHugeBot taking the opportunity here to damage Black's kingside structure, and now Black's king might struggle to find a safe home. And TinyHugeBot has already found a nice way to crash through, and this will be checkmate very soon, I imagine. So the astounding efforts of the duo behind TinyHugeBot have earned them the formidable ranking of 13th, meaning of course that they'll be advancing to the knockout round. Next up, Electric Shockwave Gambit by Valentin is an interesting attempt to try and exploit a loophole in the rules. I had specified that bots were not allowed to create any new threads for running code in parallel or in the background during the opponent's turn. I thought that was some bulletproof legalese, but this bot argues that it's not breaking any rules simply by creating this unused Shockwave object and then forcing C#'s garbage collector to run. The idea is that when objects are cleaned up by the garbage collector, it triggers this optional finalizer function, allowing you to manually deal with any unmanaged resources you might have. And while this does run on a separate thread, it's technically not one that was created by the bot. So what the Shockwave Gambit does in here is, during the opponent's turn, it forces the garbage collector to constantly count and recount the amount of memory currently in use by the entire program, significantly stalling the opponent while it's thinking. I thought that was a very creative idea, and the only reason it's not very effective is that the bots in this tournament are actually being run in their own isolated instances. But even though the Shockwave failed, it still seems to be a pretty strong bot from the looks of it. We can see it has a nice little evaluation function, simply counting up the piece values, telling pawns to move forwards, and encouraging pieces to go where they control lots of squares, and attack or defend many other pieces. Along with some endgame stuff to help push the enemy king towards the edge of the board by bringing one's own king closer to it. And like most entries, it uses a minimax search with alpha-beta pruning for searching through positions. SimpleMCTS by Gino Pirota is one of just a few bots to try using a Monte Carlo tree search instead. I know almost nothing about this technique, so let's take a look. Inside its brain, we can see there's a little loop that calls this iteration function over and over again. This is called with a depth of 20, which means that each time the function will play out some sequence of 20 moves from the current game position. At the end of those 20 moves, it then evaluates the resulting position by just counting the material, and giving a little bonus for having pieces developed, where being developed is defined as being inside of this mask, representing this block of squares. There's also a big penalty for being in check. Now, after each move, it updates a counter for the number of times the current position has been reached, and also keeps a running total of all the different evaluations that have been reached from this position. So I guess unlike a minimax search where the evaluation is supposed to be as accurate as possible having searched through all the possibilities to some depth, in this case it's just the evaluation of one random sequence of moves that could happen from here, being added onto the evaluations of all the other random paths that have been explored from this point so far. Well, I say random, but it's actually smarter than that. To choose a move to look at next, it weighs up the possibilities using this little equation called the upper confidence bound for trees, which essentially prioritizes exploring the move that currently seems to be best, in order to increase the confidence that it really is as good as it seems, but balances that with looking at moves that have been explored relatively little, since even if they seem bad at the moment, it's possible that with more exploration, we'd discover that one of them is actually the better option. And then there's also an extra incentive for looking at moves that capture a piece, or put the opponent in check. Alright, so as we saw, this function gets called over and over until the thinking time has been used up, at which point it plays whichever root move was chosen most frequently during the search, since by definition, that's the one that the algorithm thinks has the highest probability of success. So let's see how this plays against the electric Shockwave Gambit. It's a bit of an odd place to go with the knight, and now this position already seems rather awkward. Black needs to bring back the bishop or use the other knight to block the attack on the queen, because if it blocks with the pawn, then white can take, and suddenly the threat of capturing on g7, attacking the rook, the queen, and the knight all at once is just a total disaster. Unfortunately, that's exactly what SimpleMCTS has decided to go for, so we can see that it does struggle with basic tactics. It's an interesting approach though, and definitely something I'd like to learn more about and experiment with in the future. So Shockwave Gambit came in 61st place, just squeaking into the knockout round, while SimpleMCTS came in rank 236. Out of interest, let's actually see it playing against Phoenix Chess by Matthias, which was another bot that tried this Monte Carlo approach. Having watched it play for a bit, it does also definitely suffer from the same sort of basic tactical oversights as its opponent, so it's clearly a tricky technique to get working well, especially with the token limit, and so it's no surprise that most people went with the traditional minimax approach instead. Still, I'm happy that some people tried it out anyway, and if I do another coding challenge like this in the future, I'd like to figure out something where these different sorts of approaches are on more of an even footing, so let me know if you have any thoughts about that. In any case, after a somewhat strange game, Phoenix Chess has emerged victorious, and in the tournament went on to do pretty well, ending up in rank 176. Next, let's take a brief look at ILVM by Vincent01, which is an interesting entry because the author decided to focus less on writing a chessbot and more on simulating a computer to run the chessbot. So the IL in the bot's name stands for the intermediate language that C# is compiled to, and VM is a virtual machine. So much like TinyHugeBot, the chess engine itself has been compiled and stored in a big decimal array, but instead of simply handing it off to be run behind the scenes, this bot runs it itself by defining its own program counter, stack pointer, memory, call stack, and so on. The code is then copied into memory, and the program starts running. So we can see here it fetches each instruction from memory and then executes it. For example, some opcodes map directly to functions in the Chess Challenge API, while others are more general, doing things like basic arithmetic and so on. What this is actually running, by the way, is apparently a depth 3 minimax search with some sort of very simple evaluation function. Now, an interesting twist on the minimax algorithm was attempted in the bot Les Moutons by Rémi and Antoine. So in a minimax search, each side is of course trying to minimize the maximum score that the opponent can achieve. But that's not quite what this is. This is a mini-max search, where we're instead trying to maximize the average score that we're able to achieve. Okay, I'm just trying to wrap my head around this concept. So normally, if all of our available moves were terrible, except for one that's good, that would be perfectly fine. We'll just play the one good move. Whereas here, that situation would be considered catastrophic, because the average of those outcomes is really bad. A very peculiar idea, but I'm curious to see how it plays. I should mention though that it does revert to the classic minimax in the case of captures, because I assume that otherwise it would just be a total disaster. According to the authors, the sheep's strange evaluation scheme gives it a strong preference for positions where it has lots of threats and captures available, which makes sense I suppose, since the average of those is probably going to look very promising. And it certainly does seem to be relishing kicking the virtual machine around right now. Okay, finally we get a trade, but white's knight seems to be pretty stuck on the back rank. My instinct as black would be to develop one of the knights here or here, to prevent white's queen from accessing the back rank, allowing the knight to be captured. The virtual machine goes for a different approach though, a much worse approach unfortunately, and now seems to be losing all of its pieces. Alright, the sheep is ramming through here, and this should be game over any second now. So in the end, the virtual machine came in rank 351, and the sheep performed a little better with a final ranking of 290. Let's now take a look at NNBot by Jamie Whiting, which was one of the few entries to attempt a neural network approach, and that was a huge challenge just trying to fit enough weights in for the network to do anything useful, so it obviously needed to be cleverly compressed. I should probably apologize for all the pain that this token limit has caused. Sorry about that. Anyway, this does use a traditional minimax search, but it then hands the end positions over to the neural network for evaluation. So if I'm understanding this correctly, we can imagine this network as having an input node for each type of piece on any of the 64 squares, and then inside these loops it activates the nodes where such a piece actually exists for one of the players. Those input values, which are implicitly just 1, then get fed forward along their weighted connections to a tiny hidden layer of 8 nodes. Actually, there's 2 sets of these hidden layers, one used by white and one by black, and having zero experience with this, I would have expected weights to be shared between them, meaning that black evaluates the position in the same way that white does. But that doesn't seem to be the case here, so I'd love to understand what the benefits of this asymmetrical approach are, or maybe I'm just confused. In any case, to get the final evaluation at the single output node, this activation function is first applied, which, as I've talked about in my own beginner experiments, allows a network to go from being a simple linear model to having much more interesting non-linear outputs. I'm not sure why it has this upper limit though, that's something I haven't seen before. But anyway, each of these values is then multiplied by the weight of its connection to the output, and interestingly, a different set of weights is chosen based on the number of pieces remaining on the board, I guess to help gradually transition from opening to endgame strategy. So those are all summed up and added together with the material value of the pieces on the board, which of course the network could take into account itself, but since it's so tiny, it's probably better to let it focus on just the positional aspects. Alright, let's see how this fares against the bot GameTech Explained by GameTech Explained. This submission actually came with a YouTube video attached talking about the process of making it, which was very cool to see, and it has some really nice visualizations of the piece square tables in particular. Now, opening up the source code, as we can't see here, this uses good old minimax search with alpha beta pruning, and evaluates positions purely based on those piece square tables. The code might not win any readability awards, but it is fun to look at. Okay, let's see how this matchup goes. So we have a 4 knights opening, which seems to be pretty popular among the bots in this tournament. And now an interesting choice by black here, winning a pawn, but of course getting a damaged kingside structure in return. Now white's managed to win the pawn back, plus an extra, but the king has been drawn all the way out into the open, which could potentially prove problematic. Alright, a nice little checkmate there by NNBot to defeat GameTech Explained, who ended up with a rank of 78 in the tournament. Meanwhile, NNBot reached the lofty heights of rank 34. Now, another bot I'd like to take a look at is King Gambot IV by Tuanth. This is a bit of a joke entry because, contrary to all established chess wisdom, the king has been encouraged to charge out ahead of his army to lead the attack. What I really like about this though is that apart from that one obviously terrible idea, a lot of effort has clearly been made to make this engine as strong as possible. For example, we can see here that the p-square tables have been tuned specifically for this engine's playstyle. That was done using this Texel tuner by GambitMCTS, and I was curious about how this works, so I've just briefly been reading through the linked paper here, and it seems like the idea is to generate a huge dataset of games marked as wins, draws, or losses, and then to run the engine's evaluation at different points in those games to see how well it predicts the outcomes overall. There's then a gradient descent step where the evaluation terms are updated to improve the predictions, and then the process repeats. So it's interesting to see the values that result from this. For example, here's the pawn endgame table from my own chess engine, which was just handmade with the intuition that pawns should march up the board to try and become queens in the endgame. If we look at the tuned version from King Gambot, however, we can see that while it agrees with that general sentiment, it's a lot more opinionated about particular squares, often for no discernible reason. Although something interesting I am noticing is that the flank pawns have been given a higher weight than the central pawns, which actually does make a lot of sense since they can really force the enemy to go out of their way to stop them, and so potentially lose control over other parts of the board in the process. Let's just have a quick glance through the other tables from King Gambit for interest's sake. So here's the bishop table, the queen table, and finally the highly unconventional king table. Okay, let's start by watching a game against that virtual machine bot from earlier to see how this strategy goes against a fairly weak opponent. We're about 10 moves in, and the king is already on f4 of all places. Letting this knight in is very dangerous for black though, and now it's the black king in fact who is running for his life. And that's checkmate. But now let's see whether this aggressive strategy will pay off against a stronger opponent such as NNBot. To the great surprise of nobody, I imagine, the answer is not at all. Despite this, King Gambit IV still managed to march his way proudly to the 56th rank. Very impressive. Alright, now I'd like to at last get the knockout tournament going, so let's quickly see the top 64 bots who've qualified for that. And in the top 10 we have Sardine by Broxholm, followed by Rigel by Antares, Inferdaniel by Inferdaniel, Tyrant's V9 by Tyrant, Thunkerweed by American Jeff, Floppy Chess by Omsk, Dripleeb by Jeff Legend Power, along with, not listed in the actual submission, but I noticed them in the source code, A Tad of a Chad, Gonyman, Kevin Stryker, Octopus, Krutz, Outer Cloud, and Table, even though he apparently didn't really do much. Okay, that brings us to our top 3, Kinglet by Skolin, World and Abyss, Small.cs by GambitMCTS and GoCJ, and finally, the winner of the Swiss tournament is Boychesser by Minus Kelvin, Analog Horse, Anonymous, Algorithm, and Daniel Kerr. So let's see who'll survive the first knockout round, starting with rank 1 versus rank 64, so Boychesser versus Spaghetto. They'll be playing 64 games against one another, with each game beginning from a different random opening position, although of course they'll both play the white and black side of each opening for fairness. In this game, we can see Boychesser has lined up against Spaghetto's king along the diagonal, while Spaghetto's trying to stir up some trouble on the c-file, threatening pawn takes d4 with a discovered attack on the queen. So I guess Boychesser should take a moment to step out of the line of fire. Never mind, Boychesser doesn't care about that, and plays knight takes f7 instead. And the game is already over. In the end, Boychesser won 62 games, drew 2, and lost 0. Okay, let's take a look at board 2, Small.cs versus LXNA. Small has sacrificed a pawn, but in return has Alex's queen in a very uncomfortable pin. So Small ends up with 2 minor pieces in exchange for a rook and 2 pawns, but more importantly it has White's king in a bit of a bind at the moment. In fact, if the White knight tries to retreat over here, that would already be checkmate. So it has to go to some awkward square like h5, but Small could then attack the queen, while vacating the b4 square for a devastating bishop check. So Alex decides to just sacrifice the knight instead, and now Small should be cruising to victory. Alex does actually have some annoying checks though, and is managing to chase Small's king out into the middle of the board. But Small sacrifices a rook to regain the initiative, and soon enough finds a checkmate. So this matchup ended with Small.cs winning 64 games, with 0 draws and 0 losses. Kinglet also had a flawless match against FroscoBot, while Driplieb conceded just 2 draws to the Shockwave Gambit. In fact, none of the top 8 lost a single game, so clearly a pretty vast skill difference in the matchups at the moment. On the second page here, let's quickly watch a game between Rigel and King Gambot IV, because Gambot's games are usually a sight to behold. If you're fond of chess puzzles, by the way, this is a fun one to try. It's White to move and Mate in 5. Alright, so Rigel ended this matchup with 53 wins, 9 draws, and 2 losses. And if you're wondering how one of the top bots could possibly lose to the King Gambot's ridiculous antics, well, the answer is a bit disappointing. If there's an early queen trade, then suddenly it's a lot more safe for the king to wander around. So this game ended up in this position, where White has a scary passed pawn, but King Gambot was content to just sacrifice its rook to eliminate it, because its own passed pawns are even scarier. Alright, let's look at the results for the rest of the matchups, and I see that the TinyHugeBot has made it to the next round, and then here's the next page, and the last page, where I see that the neural network bot has been knocked out by a bot called Elganon. So with half the bots eliminated, that takes us to the round of 32, where each matchup will now consist of 128 games, since the competition is heating up. Well, at least a little bit, with Boy Chesser losing 1 game to Volker, and Small.cs losing an entire 2 games to Tuna Tactician. Alright, let's take a look at how the matchup is going between Kinglet and Elganon. So Kinglet castling queenside here, and Elganon seems to be lagging a bit behind in development, with the king still stuck in the center. Okay, this is looking very scary for black now, and Kinglet finds a sneaky little knight fork, which black of course cannot capture on account of queen b3 leading to checkmate. And now we have the queen and bishop working very nicely together to hunt down the king. So in this matchup, Kinglet won 97 games, drew 29, and lost 2. Then let's see how Driplieb versus FOMBot is going. Okay, so after some strange opening moves, Drip has managed to gain an enormous amount of pressure along the f-file. Knight f2 is a funny looking move, but I think the idea is that black really wants to take this pawn, but the bishop is hanging with check. With this last knight move though, black now has the threat of playing knight h3, after which wherever the king moves, the pawn capture comes with the added bonus of checkmate. So FOMBot tries to defend the pawn with the rook, but with all its other pieces still stuck on the other side of the board, there's really no way that the king is escaping this attack. So this matchup ended with 100 wins, 25 draws, and 3 losses for Driplieb. And here's the rest of the results on this page. Then on the second page, I want to quickly mention a bot called Cosmos by Gonyman. Like many of the top bots, it's using a set of popular public p-square tables called Pesto, which have been tuned for some pre-existing engine. The big problem with these in this challenge, of course, is that they take up a lot of space, and so a good deal of effort was put into compressing them. Gonyman, for example, actually made a whole write-up about their approach, where they used a genetic algorithm to try to evolve part of the solution, which I thought was a fun idea. The details are beyond the scope of this video, but it's very impressive to see the clever techniques that people have come up with. And here, by the way, is a visualization of all the original pesto tables versus the lossily compressed versions that this author has created. I can't say I've fully wrapped my head around what's going on in the code here, but clearly some very nice work nonetheless. Just for comparison, Cosmos's opponent in this round, the TinyHugeBot, also used the pesto tables in its evaluation, but due to their shenanigans, they were able to get away with a lossless compression scheme, which we can see has taken up a lot more space. In the end, it was a pretty close matchup, with TinyHugeBot winning 51 games, drawing 46, and losing 31 to knock Cosmos out of the running. And here are the rest of the results. That takes us to the round of 16, and in the interest of time, let's just skip straight to the results for this one. And we can see that Velocity++ has been knocked out, as has Uranium, Sentinel, TinyHugeBot, AceV1, John, Sardine, and Infierdaniel. Well done to all of those for making it this far, but now we're down to just 8. One bot I want to highlight here is Tyrant's V9. At some point during the tournament, someone actually made a live leaderboard where the bots could play against one another, and Tyrant was a name I noticed very often being at, or at least near to the top. I believe that this was the strongest bot to be open source throughout almost its entire development, only going private in the last few days for some final tweaks. Because of that, it was extremely influential, and in fact it's explicitly referenced in at least 33 different entries that I've seen. Tyrant then also mentions a number of fellow competitors who helped with the creation of this bot, so it's really cool to see that there was so much collaboration going on in this challenge. Anyway, let's see if this bot is able to take down Small.cs to make it into the semifinals. We've started out with some sort of French defense here, and I don't know much about this opening, but I can't imagine Tyrant should be too thrilled to have given up the light square bishop already. Alright, Small is going to have to make a slight weakness on the king side in order not to get checkmated there, but in return is managing to win some pawns on the queen side. In this position, I was expecting Small to just recapture the knight and be very happy with the extra pawns, but after consulting Stockfish, it turns out that with moves like queen h6, in conjunction with knight f3 to g5 and pawn h5, Tyrant actually has plenty of counterplay. So Small tries something else, giving up the queen and a minor piece for 2 rooks, which seems very bad, but Small now has its eyes set on winning the pinned f1 knight. Tyrant meanwhile needs to be careful where it puts its queen. For example, trying to gain time by attacking the rook would be disastrous due to rook takes knight, followed by a royal fork on d2. And so Tyrant is actually forced to give up the knight, but is still doing fine if it just brings the other knight to f6, where after the trades, white's thorny pawn on that square means that black's rooks will forever be distracted watching out for the dangerous queen infiltration, and the game should be a draw. Tyrant chooses a different path, however, and now has a queen versus a rook, knight, and 2 extra pawns. Okay, there goes the last of Tyrant's pawns, who'll need to try and pull off some kind of perpetual check here. But Small's managing to keep the pawns moving up the board, and at last we have checkmate. So this was a very hard-fought matchup, with Small.cs winning 203 games, drawing 163, and losing 146, to eliminate Tyrant's V9. And here are the rest of the results: Boychessa defeating Rigel, Kinglet defeating Thunkerweed, and Driplieb defeating Floppy Chess. So, we arrive at last at the semi-finals, where, in whatever the opposite of a dramatic turn of events is, the 4 finalists are the same top 4 bots from the Swiss tournament. I thought that the results from that would be a lot noisier on account of so few games being played by each individual bot, but oh well, it's nice to be certain, I suppose. So let's see who'll be our first bot into the final round from the matchup between Boychesser and Driplieb. Boychesser has taken on a slightly damaged pawn structure here, but we'll have to see if its opponent is able to exploit that. Now it's going for some aggressive pawn moves on the king side, although that white queen on h6 might be difficult to dislodge, and Driplieb can definitely think about launching its pawns at black's king too. Okay, we have a trade of knights, and now Driplieb is coming after Boychesser's king with a vengeance. This bishop move is a bit awkward looking, but the idea is that if black were to accept the sacrifice, white could then trade off the only piece that's really helping to defend black's king from the attack. So white could then trade on g6, forcing black's king onto the newly open h-file, after which Drip could simply move their own king up one square, creating the unstoppable threat of rook h1 checkmate. So Boychesser plays rook f7 instead to add another defender to the king, but white has the upper hand and just needs to find the exchange sacrifice rook d5 to secure the advantage. Instead, Driplieb tries the move c5, indirectly attacking black's queen, while adding yet another attacker to black's feeble pawn center. Boychesser decides now is a good time to capture that bishop though, sacrificing its queen, similar to Small vs Tyrant in that last game we saw, although here there's no extra pinned piece to even things out. Instead, what Boychesser has seen is a way to crash through with the pawns, and ultimately force Driplieb to give back the queen. So despite Driplieb clearly being a strong and dangerous opponent, Boychesser managed to win this matchup with a very convincing 622 wins to just 109 losses to advance to the final round. To see who'll be joining it in the finals, let's take a look at the match between Kinglet and Small.cs. Kinglet is playing a very risky game here with the king still wide out in the open, and has now set out to win a bishop in exchange for 2 pawns, one of which Small has pushed all the way down to f2, just 1 square away from becoming a queen. After some maneuvering, Kinglet has managed to win that pawn, but despite now being almost a full piece up, white's extremely exposed king means that black could actually gain the upper hand with the move d5, creating a new passed pawn. That's because if Kinglet were to get greedy and capture it to make a passed pawn of its own, Small could then offer up another pawn, opening the way for a crushing attack with the queen. That opportunity was missed, however, and after some back and forth, the game ended up in a complex but equal position, where Small has just enough counterplay to make up for the missing piece. Basically, it needs to keep an eye on white's passed a-pawn, hold on to its own annoying h-pawn, and make sure it always has some checks available to harass white's king, so under no circumstances trade queens. Alright, with that dubious decision, Small is now in serious danger of losing the game, if Kinglet is just able to navigate this tricky endgame. This is the infamous bishop and knight versus king endgame, and in order to win, Kinglet has to somehow force black's king into a light square corner, so that the bishop can deliver checkmate. Let's see how it goes. Okay, so an interesting game I thought, but despite this nice victory, Kinglet was unable to survive the match against its formidable opponent, who won 404 games while losing just 298. So, our final matchup of the Tiny Chessbot Challenge after all these thousands and thousands of games is, who could have seen it coming? Boychesser versus Small.cs. Before we get into it though, let's finally take a look at the code behind these two extremely impressive entries. Starting with Small.cs, the first thing I noticed is how thoroughly the code has been documented, with links to read more about the different techniques and so on. It's essentially a guide to making a chessbot, which is very cool. Now down here we can see that it's extracting some p-square tables and other evaluation terms, but then interestingly it's repacking them into a different format, where each integer contains both the endgame and middle game weight. Let's go take a look at the evaluation function quickly to find out how that's being used. So over here it's looping over all the pieces on the board, and first of all giving bonuses for open files and penalties for doubled pawns. Then there's also a mobility bonus given based on the number of squares that each piece currently attacks, which is something that many bots did, but an extra detail here is to actually weight that mobility differently depending on what type of piece it is. In particular, it seems that bishop mobility is considered to be twice as important as rooks or queens for whatever reason, while the king is actually penalized for being able to move, to try and keep it sheltered early on. It also gives a bonus for the number of squares around the enemy king that each side is able to reach, and these are also weighted based on piece type, with rooks considered more important than queens, interestingly, until the endgame, at which point it's apparently bad for the rooks to attack the king. This defies logic to me, but all these values have of course been tuned across millions of positions, since as you may have noticed, this bot was co-authored by the creator of that tuning program we saw earlier. So I guess we'll just have to take its word for it. In any case, the bot then scores each piece based on its type and location, although an interesting trade-off was made here actually. Rather than storing a value for every single square, it approximates it as the sum of a file score and a rank score. This approximation apparently lost about 20 rating points over the full p-square tables, but of course frees up a lot of tokens for extra features. Finally, the individual middle and endgame scores are extracted from that packed score format it's using, and it just interpolates between them based on the amount of material left on the board. So a really nice and compact evaluation function, but let's now have a look at how it actually searches positions. Like all the top entries, it uses an idea called iterative deepening, where the current position is searched over and over again, but each time going one step deeper. This means that no matter when the allotted time runs out, it will always have a usable answer. As I talked about briefly in my first chess programming video though, it does seem like a colossal waste of time to keep redoing the same search, so I wasn't surprised to see many people opting for more intuitive approaches, like always using the same fixed depth, or trying to guess a good depth to use at the outset, based on the time and number of pieces remaining, for example. The reason that iterative deepening works though is that alpha-beta pruning is extremely sensitive to the order in which moves are searched. So if you mostly look at bad moves first, your search tree might look like this, where the grey nodes represent the few parts of the tree that the search was able to skip. Here's the same tree now, but searched in a much better order, and we can see that huge chunks of it have been completely cut out. So the beauty of iterative deepening is that one can use information from the shallower searches to improve the move ordering of the deeper searches, making it counterintuitively very fast. Another way that Small.cs and many other top bots capitalize on the information gained from shallower searches is a technique called aspiration windows. The idea is to take the score we get from each search and then make the prediction that the next search is going to find a score that's pretty similar to that, maybe within around half a pawn more or less. So we let the search operate under that assumption, which allows it to cut out more parts of the tree and get to the answer faster. But there is a chance that our assumption is wrong, of course, and the score is outside of the expected range, or window. What that means is that the search will have cut out parts of the tree that actually shouldn't have been cut out, rendering the score unreliable, and so we just have to do it again, this time with a broader guess for what the result will be. But on average, it should speed things up. Along with this, an idea called principal variation search has been used, which assumes that the moves have been ordered so well that the first move in the list will actually be the best move reasonably often. So it does a full search for the first move, well, within that aspiration window anyway, but then the remaining moves are searched with a zero-width window, which means that we can relatively quickly find out whether they're better or worse than the first move, but not how much better or worse. Of course, if they're worse, we don't care how much worse, since we'll just go with the other move in that case, and we've saved time. But if they're better, then we do need to find out how much better, otherwise we can't judge it against the rest of the remaining moves, and so we have to waste time searching that move again. Like before though, this should hopefully speed things up overall. Okay, there are many other clever techniques that have been implemented here, such as null move pruning for example, where the idea is to imagine that the opponent is allowed to make two moves in a row, but as a compromise we don't look as far into the future as we normally would, And then if our position still seems to be really good despite skipping our turn, we assume that that's too good to be true, in other words that the opponent will choose a different path earlier on in the tree, and so we avoid having to do the full search over here. Now, as we can see, these are all established techniques that anyone can look up how to use, and indeed many of the bots in this challenge have drawn from different combinations of these concepts, among others. So it's natural to wonder what makes small.cs stand out enough to have made it to the finals. I think a major aspect of it really comes down to an incredible amount of experimentation, patience, and in-depth understanding of the techniques, of course, to really be able to figure out and test the subtle details that actually get the most out of each technique in one's own particular engine. And we can really see that on display in this log that the authors provided, listing every change that was made to the bot, along with how many tokens it used and how many rating points it gained. For instance, here's the entry for those aspiration windows, which used up 38 tokens and gained 36.8 rating points, plus or minus 10.6. And this document goes on and on. Only increase reductions in late move reductions for 0 window nodes if we are not in check, gained 0 rating points, plus or minus 3.3. So an impressive showcase of the detailed and methodical testing that was done. With the possible exception of entry 1.54, I changed something in evaluation. Alright, let's have a look at one of the games from the final round. Small going for an early h4, so already a very interesting pawn structure right out of the opening. And Small now deciding to move the king into this little cubbyhole on f2. Okay, an aggressive pawn move kicking the knight away, and now actually offering a pawn sacrifice, which Boychester accepts, and Small immediately hops the knight into e4, which is a great square and also sets up a little trick with rook takes bishop, and after the recapture, bishop g5 would now trap the queen. So Boychester retreats the bishop, and now White's bishop swings into action. Okay, neither side fond of castling today apparently, and Small decides to sacrifice a second pawn to bring the queen into the attack as well. So Boychester requests a queen trade, which Small promptly declines. And it looks like Small is now managing to get one of its pawns back, although it's worth mentioning that that knight is pretty much stuck on h7. I really don't see how it's getting out anytime soon. Taking the knight away from e4 seems a little strange to me, but I guess it didn't want to allow Black's knight to sit on e5, and so has traded them off instead. Alright, a funny little knight move by Black, taking advantage of the awkward placement of White's rook and knight. So Small just ignores it, and is now starting to line up along the light squares, while Boychester dances the knight around into e5 after all. Now a funky looking rook move, but the point is that if Black captures it, a line has been opened up allowing this knight sacrifice, followed by mate in 2. So Boychester responds by actually sacrificing a piece to stave off this powerful attack. It only has one pawn in exchange for that piece, but let's not forget that Small's knight is still effectively trapped on h7, so Black has some hopes left at least. Alright, we can see that Small's trying to sneak the knight out the back, but eventually has to give it up. In the meantime though, it has managed to snag an extra pawn. But I had a look at what Stockfish thinks of this position, and it says that if Boychester just plays the logical move of bringing the rook behind White's passed pawn, it should have very good chances for a draw. But it decides to keep checking instead, and suddenly things are looking very dire. Small's king is just in time to protect the pawn, and from here it's of course all too easy. So a nice victory in this game by Small, but let's now take a peek inside the brain of its rival. So the first thing we can see is a big blob of evaluation data packed in here, and if we look at the evaluation function, it's using the same nice idea we saw in Small, of putting both the middle and endgame weights into a single integer so that it can operate on those both simultaneously. Then it's looping over all the pieces of course, but it has this funky line of code to split pawns into two separate types of pieces based on whether they're on the same side of the board as the king or not. And we can see here that the pawns on the same side as the king are considered to be more valuable, which makes a lot of sense, and is a nice little detail that I haven't noticed in any other entries. From how oddly specific these values are, by the way, they've clearly also been through some sort of automatic tuning process. Anyway, back in the evaluation function, we can see that the material is added up over here, and then the p-square tables are factored in as well. And this also takes advantage of the two separate pawn types. So if we take a look at the tables for pawns on the same side of the board as the king, we can see that in the opening and middle game, the flank pawns are generally discouraged from moving up the board, as we'd expect. However, with this second type of pawn, those not on the same half as the king, it encourages them to move much more freely, allowing Boychessa to be more flexible with its pawns, depending on which side it decides to castle. Anyway, after that, we again see this idea of weighted mobility. Although interestingly, the king is actually treated as a queen here, and if we print out the weights, we can see that its mobility has been given a negative value to encourage keeping it protected, very similar to what we saw all the way back in that Turochamp bot actually. Finally, there's some penalties applied for having friendly pawns blocking the file ahead of other friendly pieces. And here's the values for those in case you're curious. Then let's have a look at its search code, and we can see here that it's also using aspiration windows, although if it fails, it immediately abandons the idea and does a full search, rather than gradually widening the window like Small did. I doubt that one of these implementations is better than the other, by the way. It's more that every little decision in a chess engine influences everything else, and so there's no one-size-fits-all solution for any technique. You just need a ton of experimentation. In fact, the authors mention in their description running over 4 million games across over 500 different tests to try and optimize every aspect of their engine. And we can actually see the history of some of those in the branches of the Boychessa repository. I have to admit, I'm completely stunned at the immense effort that's been put into these entries. I was not expecting such strong bots to come out of this, but it's very cool to see this little challenge taken to such extreme lengths. Okay, let's see what else is in here. So this quiet to check value caught my eye, and it seems like as we get deeper and deeper into the search, the value of this is going to get lower and lower. Then this is used all the way down at the bottom of the move loop here, where it determines the number of non-capture moves that Boychessa will consider, before it just completely rejects the rest as probably bad. That's interesting to me because in my own chessbot I've tried doing shallower searches for less promising moves, and in fact it does do that here as well, but I haven't tried just ignoring certain moves entirely. I guess it makes some sense though to think of it like a gradual transition into the quiescent search. Speaking of which, we can see that when it's searching through only the captures, it uses a technique called delta pruning, which I haven't heard of before, but it seems pretty intuitive. It's just checking whether the current evaluation is so bad that even if we add the value of the piece that we're about to capture, plus some fairly large uncertainty factor, the score is still lower than what we've been able to get elsewhere in the search, in which case it just assumes that this position is hopeless and gives up on it. Now, it's amazing to me how many different features the top bots like Boychessa have squeezed within the token limit, and this was achieved by really obsessing over every detail. For example, we can see over here how a bunch of different bit manipulation tricks have been combined to be able to write this line like this, instead of like this, which saves a handful of tokens. But this team, as well as the team behind Small.cs by the way, is accustomed to caring about every single character of code, because they actually take part in something called the Top Chess Engine Championship 4K, where an entire chess engine, including move generation and communication protocol, needs to be written in just 4 kilobytes. Their engines are ICE4 and 4KU respectively, the code for which looks like this. So if you're looking for a more hardcore chess programming challenge after this, I have some links in the description about where you can get started with that. In any case, let's have a look at one last game from the final round before we see the results. So Boychessa having a deep think about recapturing this knight here, and now offering up a rook which Small quickly accepts. But that was definitely a risky piece to take, because now the king is wide out in the open. Okay, it looks like we're getting a queen trade, which I feel like Boychessa should have tried to avoid, because now white's out of any immediate danger. At any rate, Boychessa is left with a pawn and an extra bishop in exchange for the rook. Small meanwhile needs to try and get its pieces developed, because right now they're not really doing much. Instead of doing that though, it seems to be setting them up for the next game. So Boychessa is doing a good job, I think, of keeping white quite constricted here. Alright, Small sacrificing some pawns to try get its pieces out finally, but now black is suddenly 3 pawns up for the exchange, and the pair of bishops is doing a fantastic job of preventing white's rooks from infiltrating. Now Boychessa's king is getting involved to help support the pawns. And we have a trade of rooks, and finally these pawns are on the move. So if black can just get rid of white's pesky knight, then it'll be able to make a queen. Actually, Boychessa decides to promote it anyway, since the recapture runs into a skewer. So Small only has the rook remaining to give some checks with, but those will run out very soon. And now a second queen is sacrificed to get rid of the rook, and finally a third queen is made to finish the game. Okay, let's at last see the results of this final matchup. So out of 1,024 games, Boychessa won 437, drew 403, and lost just 184, to become the TinyHugeBot champion. Alright, all that remains now, I suppose, is the closing ceremony. Thank you so much to everyone who took part in this. I hope you had fun, and maybe learned something new along the way. I've certainly learned a lot just from looking through all the submissions. And a final congratulations to the teams behind Kinglet, Small.cs, and Boychessa for creating such formidable bots and making it all the way to the top 3 of this tournament. Alright, thanks for watching, and until next time, cheers. Oh, actually, I thought it might be interesting to see how Boychessa compares to the bot that I created over the course of the 2 coding adventure videos. Obviously, it's not exactly a fair fight since I had no token limit whatsoever, but let's see how it goes. Okay, so Boychessa is winning this game, surprise surprise, and I actually had them play a bunch of games out of interest, and in general, my bot gets completely crushed. Thankfully, I've picked up a lot of new tricks to try though, so one day when I get back to chess programming, we'll have to have a rematch. Alright, that's all for today, so goodbye once again.